Hello and welcome back. If you follow the channel, you know that we recently got hold of an HP 5245L Nixie counter, released in 1963. It became the king of frequency counters in the 1960s and was used in the Apollo tracking stations. This is a beast of a machine, made entirely out of discrete transistors. Ours was very sick and it took 2 rather arduous episodes to get it back on its feet. But fixed it we did, and its beautiful Nixie display is now counting frequencies up to 50 MHz, as Bill and Dave intended. But that's not all. The HP 5245L supports all kinds of plugins. In the last video, we repaired the HP 5253A converter, which extends the counter operation up to 500 MHz. Then there's the next step up, which is 0.2 GHz to 3 GHz, which is the one I really want because that would work for our Apollo S-band setup. The HP 5254A was introduced in 1964. It was a large leap forward, extending the counter operation well into the microwave range, up to 3 GHz. But like its brethren, its front knob is completely frozen and won't budge. Let's see if we can bring it back to life.
We apologize for the following short bout of potato vision.
Okay, we now have 2 good ones, getting us up to 500 MHz. So let's see if we can get the 3 GHz one working, which will outperform this guy. And the higher you go in frequency, the more complicated it gets. So there's more stuff happening in this one. Let's open it up. And it has the same problem, it is completely stuck. Ooh, okay, so a lot more adjustments. So this plugin works in exactly the same fashion as the one we explained in detail in the previous episode, working on the principle of down conversion. There is still an oscillator derived from the main instrument, driving a step recovery diode to generate harmonics, a cavity resonator to select one of the harmonics, a mixer to down convert the signal, and a video amplifier. Everything is just way more complicated to work at 6 times the speed. If you look here, that's a broken tooth. That's a problem. Ooh. And then the video amplifier is a much more complicated animal. I haven't opened it up, but here is the schematic. You can tell it's quite involved. It has the pickup is a microwave part that's in the cavity. It has a filter to it because they want to filter the higher harmonics. So it's a whole lot more complicated and a whole lot more microwavy. A bit harder to take apart. The meter hangs the whole thing, and then also the output coax hangs the whole thing. So I have to desolder this and then to unscrew this. Okay, bye meter. Alright. There we go. And let's look at the mechanics. Oh, plastic gear. Okay, that one's going to be a challenge. It has a tooth that's missing. For the front, they have gone plastic. Okay, so that. Gooey. Which leaves us with this assembly here. The only problem is to get that gear loose without breaking it. You can see the grease that has congealed here. Okay, good news is that, oh, great news that the cavity is not stuck. Okay, so it's just that gear to that gear and getting the plastic one unstuck. In the meantime, I got movement in the double idler gear assembly here. So, top gear. Yee! Over greased. So actually the broken teeth, good news, that seems to be made on purpose. That's good news, bad news, because we'll have to retime it right, but that's the end of travel. Okay, I got that one all freed up. But this one, despite seeping it with WD-40, it doesn't want to budge. I'm going to try the razor blade and hope that it doesn't shatter. Man. Aha! Here we go. Come on, don't shatter. Got it. Okay, I eventually took everything from the shaft out, except that I left the plunger in the cavity, but it's all freed up. And the only problem I have left is this, which has shrunk. It just won't go back in. So I guess it goes in the lathe as the next step.
I passed the program counter actually counting last night, but it took me 2 hours of thinking that I... They put 4 different things in there. They'll put like one bit of view with the asynchronous assignment.
Alright.
Put the delay after the
That
asynchronous
works.
assignment. That does just like a straight up.
Excellent. Okay, it works again.
Soon after.
Okay, she's all back together, and we have 1 gigahertz over here, courtesy of my HT8662A, and off we go. We need to get on the plug-in setting. It's counting something it should not count. Oh, I'm at the max here. So I'm hitting a hard stop here. But if I go the other direction, I'm hitting a hard stop there. I can actually hear it. So why is it not going the whole way? And then I'm never seeing any meter indication or any output over here. Alright, not working. So I got some life out of it. If you look over here, this is the output of the video amplifier. There is a trace up to 50 megahertz, which is what it's supposed to do, so it has some noise. And I see a mixing product, but it's a little bit wonky. It's very low, and if you follow how it moves with the frequency, it's doing the right stuff, but the zero is at 634 megahertz. It should be at 600 or 650. So it looks like I'm generating the wrong harmonics. I would think the multiplier is wrong. I'm multiplying by the wrong frequency, maybe. So that's how this instrument works on the excitation side. It gets a 10 MHz from the counter, an amplifier, by 5 multipliers, so I should get 50 MHz, multiple of 50 MHz, then it's amplified. Then there's the harmonic generator, and then the cavity. So let me check if that works. That would be, I believe, this assembly here. And there's a quartz filter that's super resonant in there, so if that's wrong, something might be wrong.
A few minutes later.
Alright, it didn't take very long to figure out what is wrong, so I looked at the 10 MHz coming in, and then if I had something after the first transistor, and if I probe on the collector of the first transistor, I have a little bit of it, but not much. Then I look at what was coming in, and I got nothing. It's living on fumes. And so very quickly I looked at where it got its input from, and it's from my test cable. So here's my beautiful extension cable. It says in here that those two are wired together. Then you look at where the input signals come from. It comes from here, and it goes to the top lead. And in the schematics it say that those two leads should be connected, but they are not. And guess where it is in my input cable? It's on the bottom lead, so it's just not connected to the input. Let me rectify that. Okay, big fat connection now. Let's see if it works better. Yeah, there we go. Okay, that's 10 MHz. Alright, this is much better. I have a big nice signal here. And you can see the needle is working. It's not great, but it's there. I'm completely off here, of course. And this reads something reasonable, that this should be 10 MHz off. Wait, I'm 620. I should read 20, not 10. So I'm getting there, much better. There are many things to tweak. I might be on the wrong harmonic. Actually, they don't say anything about the tuning, but I could figure it out from the schematics over here. So make sure I get 10 MHz peak here, then 50 MHz peak there. Then there's this bandpass filter that's very narrow, so this probably needs adjustment too. And then just amplifiers. So I'm going to go stage by stage with a spectrum analyzer and peak it. So this is my 10 MHz peak right here, and I'm going to make it as big as I can. Ooh, that's fairly far off. I gained a good 10 dB right there. Alright, let's keep going. This one. This is the times 5, I think. Alright, here we go. It's over here. Frequency 50 megahertz right here. So it's my times 5. It's not bad, and it has a coil before and a coil after. Okay, so that's pretty much maxed. And that's the coil after and the collector. Okay, so that was pretty well tuned. And here's the output of my after my crystal filter. The goal is to get rid of all the harmonics around it, and it did a good job. Doesn't seem to make much of a difference here. Okay, so not that dramatic of a change. Gain a few dBs here. So I'll fuss with it, but that didn't seem to be a big issue. It was aligned properly. Okay, so after tweaking, I arrive at this pleasant 50 megahertz with 3 dBm, fairly clean. Yeah, after all these adjustments, I'm not sure it did me that much good. That minus 7 dBm input, I'm still in the red.
Moments later.
So I'm going somewhere in a weird way. This is 1.04 megahertz, and I'm reading the 0.04. And I have plenty of signal, and I see it right here, a nice product mix. I can change it a little bit. So that's all doing fine, except my cavity here says 0.2, and if I turn here, I hit the stop. So there's something really cheesy with the cavity is completely off. I need to take the freaking cavity apart once again. Okay, I got it. Remember the tooth that was off? Yes, it's on purpose. And that's the end of travel. And what happens is that it collides with another tooth that's over here. There it is. This guy right there. And when the world is perfect, they collide together and they prevent me from going past something. But I have no idea how to time this. So I think to solve my problem, I had to dismantle the whole thing again, and that's all the gears that are on the, and all the gears and all the pieces are on the mechanism. And I think I need to take out the only gear that is still stuck and I didn't touch before. That's the one that has the little piece sticking out that causes the hard lock, and I have to retime somehow. Sure enough, this gear is stuck very hard. I don't want to mar the shaft either, man. It's stuck really hard. So we'll allow for the special use of WD-40 just in this case. Yeah, it's worked. Woohoo! Okay, and I think there's a groove actually that tells me where it goes. Okay, so that's very good. So now it spins beautifully, so all I want to do is remount the whole gears. The whole gear train in order. The springs, the washer bearing, the plastic ball bearing, top part. There you go. There you go. Now I can bring it to a point where it sticks, and then it takes 1, 2, 3, 4, 17, 18 turns, and then it sticks again. It's at a stop, so this is a line, and that is, it went past this one. So if I put it over here, then it's going to be a little past here. And a little past there. Okay, so that should be where the stop is. Okay. So now I'm rehooked live, and I have to find where the hell I am with the cavity. I camp around 1 gig, and I just turn the cavity until I get there. There you go. This is 1 gig. Go to 110, and if I get the product over here, okay, so I'm assuming this is the 1 gigahertz point, and I'm going to tune the cavity back down to 200 megahertz, because now I can follow it, right? So let's go instead of 100. Okay, 900. And the dial also should be this way. There we go. Second difference, first difference, 810, 600, 400. Okay, this is 210. It's 210 megahertz here, 210 here, 210 here, which means this is the 200 megahertz harmonic, and I am correct with my marks. This is where it's going to hit the end, and I am right where I should be. Okay. Now I retighten my gear, and I should have my cavity back where it should be. Retighten the gear here. Retighten it there. And let's see if we have done it approximately right.
More moments later.
We repaired it. She's all back together. Okay, so now if we go and get it on 1 gigahertz, and it has plenty of conversion gain. It displays it exactly at what it should be. And if I go to the other end, it stops right here, which is the one I set. And actually the upper end, it stops on its own there. It never goes past what I thought it would. And back to, and this is 1 gigahertz plus 10 megahertz. And then if I put that 0.2, it should be pretty close to it. Here's 210. Yeah, and it's almost perfect, and it stops right afterwards. So I have it dialed to perfection, and so with that thing we should be able to measure the Apollo frequency. So here we go, we've done it. It's 1963 all over again, and we have our digital Nixie counter high end. I am at 2.1064.06. That's the Apollo uplink frequency, and over here it tells me, like in the good old time, 2.16406, exactly as it should be, and exactly as it was measured, because this is the instrument they had on the ground stations to check the receive frequency and the send frequency of the S-band system for Apollo. Here you go. Microwave frequency counting digitally in 1963. How neat is that?